right, so what we're going to be talking about the rest of this week, and I think maybe one day next week, I'll have to look at my schedule. We're going to be talking about similar triangles. Okay, we've done something, no pun intended, similar with congruent triangles. We talked about triangles being congruent and proving them congruent. Now we're going to do it with what are called similar triangles. Okay, so similar means that two figures have the same shape, but not the same size. Okay, so it's like clip art. Okay, so if you have a piece of clip art, you know how you can drag the bottom corner and you can stretch it? You know, if it started out as a pine tree, when you stretch it, it's still a pine tree. Right? It's now a different size, but it's still a pine tree. Or, well, we'll get to that in a second. Okay, so similar triangles have three pairs of corresponding congruent angles. So all of the angles are going to be congruent. All the corresponding angles are going to be congruent. What's different is that corresponding sides are going to be proportional. They're in the same ratio to each other. So with congruent triangles, corresponding sides had to be exactly the same. They had to be congruent. But with similar triangles, they're just going to be in the same proportion, in the same ratio. And we're going to look at that here in a second. Remember, corresponding just means that they're going to be in the same position. Proportional means that they have the same ratio. So here they have an example set up. And this is how they show, instead of sides being congruent, this is how they show that sides are proportional. So they're saying AB over DE is equivalent to BC over EF, which is equivalent to CA over FD. So literally they've said 8 over 4 is equivalent to 6 over 3, which is equivalent to 11 over 5.5. Is really what they're saying right here. Again, because we don't write them out as congruent because they're not congruent. This is how we show they have the same proportion. Okay, and then the corresponding angles have to be congruent as well. Okay, so this is our similarity statement. The similar symbol is just the tilde. Remember, with congruent, we have the equal sign with the tilde. Similarity is just a tilde. It's just a little squiggle. But we finish congruency statements the same way, or we finish similarity statements the same way we did as congruency statements. So what angle has to correspond with A? D. What has to correspond with B? E, and then we have F. So there's a lot of things that are going to look very familiar to you, which is nice. Few differences. All right, so at the bottom here, we're just going to find the missing sides and angles. So we are given a triangle JKL similar to triangle MNO. So first of all, let's find angle L. So solve for angle L, please. So if we have a triangle, we know how many degrees there should be. What did you get for angle L? 45, good. Okay, so what does angle O have to be then? Also has to be 45. What's angle N going to be? 60, good. All right, so now, we're going to spend a lot of time solving for sides tomorrow. But notice that we have two parts that match up here, JL and MO. So the ratio is 9 over 3, or just 3. Okay, so they would have to divide by 3 to go from the left to the right. So if I want to divide by 3, 6 divided by 3 gives me 2 for NN. Okay, now they want to know what divided by 3 gave me 1. So that would be 3. And tomorrow we're going to, like I said, we're going to spend a lot more time solving for sides. That one's pretty straightforward. Okay, on number 2 on the right here, they gave us a similarity statement. So a triangle QRS is similar to triangle XYZ. We're going to find matching parts here on sides and angles. So what angle has to match up with angle Q? Angle X. What matches up with Y? Angle R. How about RSQ? YZX, so angle YZX. Okay, now let's match up sides. So QR matches up with XY because they're the first two letters, QR and XY. How about RS? is YZ, and then SQ, ZX. Again, a lot of that should seem familiar to you from congruent triangles, right? And that was when we were all online, but so hopefully some of that's ringing a bell. Questions on any of that as far as what similarity means? All right, now just like with congruent triangles, we can prove that triangles are similar. Right, so you don't have to know all 6 pieces, just like we did with congruent triangles. Remember how originally said, well, we had to have 3 sets of congruent angles and 3 sets of congruent sides. We said that's way too much, so we came up with those 5 shortcuts. Right, remember side, 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 angle, side, angle, 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 side, and hypotenuse leg. Okay, well, we have shortcuts for similarity as well. Okay, we have shortcuts for similarity as well. We only have 3 of them. We'll talk about why that is in a second here. So the first one is side, side, side. So we can show that we have 3 sets of proportional sides. Then we can say if the triangles are similar because the side, side, side. The next way is side, angle, side. So again, the 2 sets of sides have to be proportional, and the angle between them, because the A is in between the S's, the angle between them, those have to be congruent. The last way, which was not valid for congruent triangles, is angle, angle. If we can show we have 2 sets of congruent angles, then we can say the triangles are similar. We don't have to worry about that 3rd angle because of the 3rd angle theorem. We talked about this a long time ago. It said if we have 2 sets of congruent angles in a triangle, that the 3rd set must also be congruent. Do you remember proving that was one of our early proofs of triangles? A little bit. Like we had like a 40-degree angle and a 50-degree angle. We found that both angles then had to be 90 because we were both subtracting from 180 on both of them. They're kind of ringing a bell maybe. But we don't have to worry about, we don't really have to call it angle, angle, angle. We only have to show that 2 of them are congruent. Don't do the extra work. Rarely does anybody really call it angle, angle, angle. They just go for the first 2. Okay? Because if you say 3 A's, then you have to list 3 sets of angles. So why do you want to do extra work? All right. So we're going to practice here to see if these, we have 2 examples here of are these triangles similar. So the first one, do we have one of the acceptable combinations? Remember, we only have 3, side, 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 angle, side, and angle, angle. Yes, what do we have? Yes, because of angle, angle. Good. So number 2, we don't have any angles. So my guess is if it's going to be true, it's going to be side, 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 right? So we really have to check. Is 7 over 5.25 equivalent to 12 over 9? And is that equivalent to 14 over 10.5? I divide them out, what do I get? You should have 1.3 repeating on all of those. Is that okay? Now, if one of those was not repeating, if one was just 1.3, then they are not similar. So every decimal, like all the decimals have to line up exactly. Make sense? Questions on any of that? Now, on this one, I compared left to right. Technically, you can compare right to left as well. Most textbooks, most tests will compare like as you read, left to right. But it's not wrong to go right to left either. All right, so on the next page here. So page 3, did I have you number your pages? If you want at some point, I would go through and number each page. So page 3 here, it says similar triangle practice. Page 4 says similar triangle practice 2. That page 2 is going to be your homework, part of your homework. okay? But this page 1, number 3, page 3 here, I'm going to give you about 5 minutes. I want you to work on this. We're going to go over it, and then we'll move on. Okay? If you get done with page 3 here, move on to page 4. That way you have less homework. But I'm going to stop you in about 5 minutes, okay?
Thank you.
right, let's go ahead and go through those. Everybody ready? All right, so number 1 should be side, side, side. Number 2 is angle, angle. 3 is side, angle, side. 4 is angle, angle. 5 is no. 6 is no. 7 is side, angle, side. 8 is no. 9 is side, angle, side. 10 is angle, angle. 11 is side, side, side. And 12 is no. They're not. Any of those you want to go over? Yes, what? Number 11. All right, so number 11, the bad thing about similarity is sometimes you have to kind of guess how it's going to be situated. Okay, so you have to kind of visualize. I feel like maybe these two angles are going to match up, like if I rotate it. So I feel like maybe 6.1 over 9.15 would match up. I kind of feel like 4.7 and 7.05 would match up. And then 8.4 and 12.6 would match up. So let's double check. 6.1 divided by 9.15 is a 2/3 or 0.6 repeating. 4.7 divided by 7.05 is again the same thing. And then 8.4 divided by 12.6. Again, I got 0.6 repeating. Now, if I would have matched up incorrectly, it's best if you kind of guess again, because it doesn't tell you, check to see that triangle ABC is similar to triangle XYZ. If they did that, then I would know what parts to match up. That's kind of the stinky thing about similar triangles. Does that answer your question? Any other questions? All right, so whatever you didn't get done on practice 2, then that's part of your homework. All right, so the next thing I want to talk about are doing proofs with similar triangles. So a lot of this is going to seem familiar again. So remember, a proof is just an explanation of why you're right, basically. You're trying to explain to somebody how this process works. I did give you a couple of reminders. Don't forget we have givens. Remember, those are like our little Christmas presents. We don't have to work for those. We have reflexive property when they share a side or share an angle. And then we have all those special angle pairs. We have vertical angles, alternate interior angles. Those are usually the big ones. Sometimes they'll throw in an alternate exterior angle, but not very often. Okay. So it looks a tiny bit different, but they're really, again, they follow that same pattern that we did with congruent triangles. So this is how they list here's our first given. They said AB over DE is equal to BC over EF, which is equal to CA over FD. So this is how they show proportional sides. So they're showing that we have 3 sets of proportional sides. It's still a given for us. But is this a good combination? Is that an acceptable combination, that we have 3 sets of proportional sides? Yes, so we can say our triangles are similar because of side, side, side similarity. Now, some people will write out the word similarity. Some people will put the tilde there. It doesn't really matter because this right here says similarity. The fact that we're showing similar sign here between our triangles, that tells me we are doing similarity. There's really, if you want to talk about marking a figure, there's not a great way to mark figures for similarities. Sometimes I'll do it with color. Sometimes I'll do it with like AB is matching up with PB. I know that BC and EF are matching up, and I know that AC and DF are matching up. Sometimes I'll do it like squiggles or straight lines. There's no good way to mark it. Okay. All right, let's look at the next one. Let's look at the next one here. It says JK over JM is equal to JL over JN. So we're doing JK and JM over JL and JN. All right, so why can I say that in my proof? is given. Okay, then they said angle KJL is congruent to angle MJN. Why can I say that?
Oh, sorry,
You're ahead of me.
Yeah.
That's also given. We're going to come back to that idea in a second. And then, is that an acceptable combination? Yes, we have side angle, side similarity. Good. Now, they gave us this angle as a given. They didn't necessarily have to give that to us as a given. Because notice those two triangles share that angle. That's really a reflexive property. If they wouldn't have listed it as a given, we could have still made that statement and listed the reflexive property here, because they have the same angle. Sometimes we would say same side, or just reflexive property with congruent sides, right? We could say same angle or reflexive property here as well. All right, so here's the next one here. Actually, you do this next one. You do the top one here. What, anyone like more time? All right, so how about the first one? Why is angle G and J congruent? That's a given. My second one is given, and then why are the triangles similar? Side angle side. Good. All right, next one. This one's a little bit different. So it says P is parallel, PQ is parallel to ST. That's our given. Now, if this proof was completely blank, we would have some options, but they're kind of leading us through the proof. And the reason I kind of kept it that way is because this is typically how proofs are going to work on the air test. They're going to give you a partially filled in proof. You have to do the proof their way. Sometimes it's like a drag and drop where you drag things in. Other times, like they'll leave like 2 rows blank, and they'll have a multiple choice, and you pick which 2 rows would be correct to fit in there. Okay. So this one they said that angle RPQ is congruent to RTS. So based on the information we have, why are those 2 angles going to be congruent? I think I heard it. Alternate interior angles. Good. So we wrote AIA for alternate interiors. All right, then they gave us that angle PRQ and SRT are congruent. What kind of special angle pair is that? Those are vertical angles. Okay, so do we have enough to say my triangles are similar? Yes, because of angle-angle similarity. Now, I said we would really have options here because we could have used angles Q and S, because those are alternate interior angles, right? So I could have used P and T and Q and S. That would have been fine. I could have used our vertical angles and Q and S. But again, because they were leading us a very specific way, we had to follow them. Make sense? All right, we're going to do one more together. Last one says AB over AE. So AB over AE and AC over AD. So that first step there is going to be what? Given. All right, our next step says that angle BAC is congruent to angle EAB. it's not part of our given this time. So really, it's just one angle, right? So why can I say that BAE and PAB are congruent? That's our reflexive property. All right, so now why are triangles similar? Side angle side. Okay, so one of the shortcuts we did not use is angle side that we use in congruent triangles, right? But we don't need this because once we have the two angles, we don't have to worry about that third side, right? It falls right in place. Does that make sense? And that hypotenuse leg was very, very specific about right triangles. That's why people typically don't use that either. Okay? All right, so here's what I want you to do for homework. I want you to finish the last three proofs. I want you to finish the last three proofs, so that's page 7. Yep, and then page 4 if you didn't get that done. So pages 4 and 7 for homework. Does that make sense? And tomorrow we're going to build on top of that.